Well, in this video, I'll be showing the design of beam in STAAD Pro. The first thing that I'm gonna do here is I'll be explaining how the beam is being designed using manual calculations. Later on the session, I'll show how it's being done using STAAD Pro. Before starting everything, I'd like to tell you that the software design is always three-dimensional analysis, whereas the manual design will be treating a 3D structure as a 2D structure. So if you're analyzing a 2D structure both manually and by using a software, you will get the same result. But if you consider the software design of a 3D structure, that will be much more accurate on what we are doing using manual design. So anyways, let's get into the presentation. Alright, it's a simple question that there is a rectangular beam which is supported over two masonry walls, and the thickness of the wall is given, which is not required in this problem, and the length of the beam is given just to be a 5 meter. Then the live load and dead load is given as a UDL, and the grade of concrete is FCK is given and FY is given, and we define out the maximum bending moment. And also it's given that we need to assume certain size for the beam, and right now in this problem I'm gonna assume the size for beam and column to be, this one will be a 230 millimeter and this one will be 500 millimeter. Alright, first we need to find out the total bending moment. For finding the bending moment, we need to find out the self-weight of the beam, and obviously self-weight is density into volume. Density of concrete is 25 kilonewton per meter cube, and this is the size of the beam. Obviously you will get a UDL, dead load as UDL, or the self-weight as UDL, and the total dead load is dead load given in the problem is 5 kilonewton per meter, and the dead load received from here, and the total sum to be 7.875 kilonewton meter. And to find out the total load, we need to add the dead and live, which comes to be 19.7.8 whatever be that live load given in the problem. This comes to be 26 kilonewton per meter, and the factor load is the load which we have received above. This shall be multiplied with the factor of safety. That comes to be 40.31 kilonewton per meter. And finally, the load is applied over a beam in the sense of a UDL. And so the total bending moment, or the maximum bending moment, comes to be like WL squared by 8. That is 14 to 5 square by 8, and this comes to be like 125 kilonewton meter. Okay, that is the maximum bending moment. And after, we need to check for a depth, and we have provided assume the depth is 500, and we are going to check whether that depth is adequate or not. The formula to find out the depth is the D is root of M by R in the B. R can be found out by using the grade of rebar used in the problem that is given to be Fe415. The R, that comes to be 0.139 in FCK. FCK, the grade of concrete is 20, and into the width of beam is 230, and the bending moment 125 is being converted from kilonewton meter to newton millimeter. That comes to be just multiplied by 10 raised to 6. That is exactly given here, and comes to be 448. The value that is 448, and what we have assumed is 500. Let's see what is the small d. That is the distance from the top of the beam to you are having rebar. The bottom bar will be right here, and after bottom bar you'll be having stirrups, then you'll be having the cover. D is the distance from the top of the bar to the center of the main bar. Okay, so and after that you might want to add the diameter of the main bar by 2 and the diameter of stirrups, and then you're supposed to add the cover to get the total depth. It comes to be like 491, which is obviously lesser than the assumed value. So hence we can say that is safe, and you might remember this formula, or you can make use of the quadratic equation to solve for area of steel. So now let's get into STAAD Pro. Okay, the first thing that we might gonna do here is just draw something. Draw a beam as having a length as 5 meter. Then let's assign a concrete section to that. So get into properties, and right in here I'll be defining a concrete section having sizes 0.5 and 0.23. So that is it, and let's assign a support. The problem is clear that the both are simply supported, so I might want to give a sort of a pin support here. So assign a pin support here. Then let's care on loading. So get into loading right here. So we're supposed to add a dead, and this one should be dead, and then we might want to add a live load here. So live is here. Okay, the first case in dead load is the self weight of the structure that is added right now, and then the next load that comes to be -5. I think 5 is applied across the beam, so we don't want to enter any parameters here. Alright, now let's get into the live load. The load value is -19. Alright, then let's assign everything to view as if there is only a single structure here, and assign to view. This one assigned to view. Alright, then we are having a combination of 1.5. In order to add that, just get to define combination and find out the factor of safety is 1.5, and we're supposed to add both loads right in here. Okay, that's all about that case, and let's get into analysis and design. Has defined a command, and I don't want to take any print out. Run the analysis and save the structure. Okay, what you're supposed to do is divide the bending moment, get into post-processing mode, and first get into combination here. And so we are having the moment is 125, so that's a simple way on equating moments. After let's try to get into the design. So here is the design. We are going to design a concrete structure. First you might want to change the units, which is maybe required or not. So it's a Newton millimeter is the preferred unit based on Indian standards. Doing everything, let's get into select parameters. Parameters are a set of variables that's required to defined before the analysis is done. So just take an example. Let's say grade of concrete is there, grade of steel is there, and right in this case, let me pick a track. Okay, there are some more parameters here, but that's not essential to pick it up. Like, you can restrict the maximum size of the bar, minimum size of the bar, minimum size of the stirrups, and maximum size of the stirrups, maximum diameter of the bar used. But I'm not going to pick all of these things. Why? Because it's not defined in our problem. And now let me select this set here and define the structure. So the grade of concrete is M20, assign it. Grade of steel is Fe415. It's solely based on our problem. Now the track is the enhancement in printing the details. If the track is 2, the section is divided into 12 parts, and each of the required area and provided area of steel is calculated by the software. Now get into commands and assign the beam. Well, that's enough, and once again get into run analysis, and let me view the output file. Scroll a bit down. You can see that the area of steel is provided here comes to be 942 right at the middle of the beam. You can see that the area is 942. Okay. The software also saw that you can use 3 numbers of 20 mm diameter bar with stirrups of 8 mm diameter, and the spacing of stirrups is 300 center to center. These are the required area of steel. As from the question, it's so quite clear that we are going to implement a singly reinforced concrete. So the top reinforcement is not provided here, but actually in order to hold the stirrups, 2 numbers of 12 mm diameter is provided here. Well, that's all about that case now. So that's the design. Before that, if you double click the beam and there's a concrete design tab here, right now we can see that the beam has been designed here. So that's a simple case of design of beam using STAAD Pro, and thanks for watching.